Hi everyone, my name is Dalton Sykes, and today with my teammates Ihao, Henrique, Will, and Bobby, we're going to talk to you about hydrophobicity and superhydrophobicity, as well as how nanotechnology enables us to better understand and explore these subjects. To begin, let's do a quick review over what hydrophobicity and superhydrophobicity are. Hydrophobicity can be broken down into two parts: hydro, meaning water, and phobicity, which comes from the suffix phobic, meaning fearing or avoiding. Hydrophobicity, then, means water-fearing or avoiding polar molecules like water. A good example of this would be like trying to give your cat a bath. Because cats are by nature very hydrophobic, it's very difficult to get them in a bath of water. When discussing materials, there are two important ways you can increase or modify that material or object's hydrophobicity. The first is to change its surface pattern or topology. You can do this either on the nanoscale or on the microscale, and later in the presentation, Bobby and Ihao are going to discuss this in more detail. Additionally, you can chemically modify the surface of an object so that it presents more nonpolar chemical groups. By doing so, they naturally segregate themselves away from polar molecules like water, and therefore increase the hydrophobicity of the object. Now that we better understand what hydrophobicity is, as well as a few ways of increasing the hydrophobicity of an object, let's briefly touch on what it means to be superhydrophobic. Well, much like Super Mario is better than regular Marios, Superman is better than regular men, and Nicki Minaj's super bass is better than regular basses, superhydrophobicity essentially takes the concept of hydrophobicity to the extreme. Superhydrophobicity can be used when an object has a contact angle between its surface and a droplet of water of greater than 150 degrees. While this is somewhat arbitrary and flexible, suffice it to say that a superhydrophobic object extremely despises contact with water and does everything in its power to reduce the contact between the two. There are many examples of both hydrophobic and superhydrophobic objects, both in nature and synthetically made. So let's look at a few of those now.